Though we have gone at length to understand what do we mean by queues and specifically priority queues, but simulating them needs an investigation into what exactly are our requirements and what is the inherent support given in Omnet++ and INET framework. In this module, we shall quickly recall why do we need priority queuing, because unless the objective is clear, we would not be able to implement what exactly we need in the simulations. We'd look at the operation in detail, then we'd look at the support in INET, and specifically the usage of the member functions. The original creator and the architect of Omnet++, Andras Varga, in his paper titled The Omnet Discrete Event Simulation System, talks about the usage of priority queues. Similarly, the reference that I have earlier shared with you on queuing and weighted round robin, other kinds of priority queuing, are mentioned in the second reference. Recall that the priority queues are actually meant to provide varied service, varied quality of service through relatively simple method in order to support both real-time and non-real-time traffic. In Omnet++ INET framework, the CQ header file and CQ library provides first in first out by default. It has to be modified in order to support the priority queuing of choice. Let's quickly see how priority queues work. The packets are first classified, and on the basis of the traffic which they carry, they are sent into their respective priority queues. The packets are taken by the scheduler from the head of the queue one by one, mainly from the higher priority queue first, and then from the lower priority queues. Within each of the priority queue, FIFO is implemented. Now, if you are planning to implement priority queuing using CQ, you have to exactly understand how can you implement priority queuing, let's say for 2 queues, 3 queues, or more. This figure gives you the summary as various flows which are entering into a queue. Instead of a single queue, we have 3 queues. The classifier takes these flows and aggregates them or groups them into various of these 3 queues and assigns them to each of these queues. And then the scheduler takes the packets from the highest priority queue, and when it is done, it moves on to the lower priority queues. In INET, CQ and cpacket queue libraries are available to be manipulated to implement your choice of priority queuing. The member function support, which is given in INET, is basically extending the queue by allowing you to create a class of priority queue that is based on a simple queue which is first in first out, but using various instances of simple queue, you can assign priority queues and weights to these priority queues. When you have created multiple priority queues, then using set scheduling priority, which is given by a short number P, you can discipline or define the order in which these queues that you have created first using simple priority queue are entertained. For example, if you create 3 classes as class A, class B, class 3, create 3 queues for them. Now, exactly how do you want the packets from these queues to be scheduled? You can implement that from set scheduling priority.